So this is our new lesson for today. And with the statistics, make sure that you are following along because statistics is a different kind of math and you can't really like Google an answer or find an answer. It's really going to be based on our notes specifically. So make sure that you are following along. Okay. So this is section 10.2 and it's talking about Venn diagrams. Go ahead and read that to yourself, the problem. Okay, if you did not read that, go back, pause the video, and read it to yourself. So pretty much he has a restaurant and he's serving chicken or fish, and it can be grilled or fried. So he can either have chicken that's grilled or chicken that's fried. He could have fish that's grilled or fish that's fried. And then they took the data from like their sales and they said, okay, what is selling? Now, this is actually a little bit complicated. Look at this Venn diagram. You have to know everything in your set. So here you have fish, here you have fried. So this has to be fried fish. Well, if this is fried fish, then, and this whole thing is fish, then this fish has to be grilled fish. So we have all the fish, fried and grilled. Well, this is fried, so then this has to be fried chicken. Okay, so we've got fried fish, grilled fish, fried chicken. What is this going to be? And that's your first step, is making sure that you actually understand your Venn diagram. Labeling, some of you don't have to label it and you just think about it in your head, that's fine. I have to label it, otherwise my head gets all confused. Okay, so first one says, what's the probability that a randomly, and again, just to make sure that our set is complete, if you were to add all of this up, what should that equal to? Good. 100%. Okay, remember that your set is like the whole thing. Because it gave you the percentages, that means it has to be 100%. And again, just want to go ahead and verify that that is 100%, just in case it was messed up or something, or there was an error. So first question says, what's the probability that a randomly selected customer would order fish? Well, probability that they would get fish is all of this. So that's going to be your 15 and your 30%. So that is 45%. Next one says, what's the probability that and you should actually try to do these a little bit faster than me. Try to do all of them and then just kind of check your answers. What's the probability that a randomly selected customer will order fried fish? Well, fried and fish. 15%. Okay, next page. Again, I have the diagram, so I don't have to be flipping over. I copied it down, but I want to label this again. So this is fish, this is fried. So this is fried fish. And again, this is fish that is grilled. And this is fried chicken. And this is going to be grilled chicken. Okay, question number 3. Probability that you get fried and chicken. Well, fried and chicken is just your 20%. Probability that you get grilled and fish And again, what is that notation? Grilled and fish. Grilled and fish is going to be that 30%. And the notation was the intersection. If Freddie serves 100 meals at lunch on a particular day, how many orders of fish should he prepare with his famous fried recipe? So how many fish orders that are fried? It was that intersection, 15%. What is the probability that a randomly selected person would choose fish or fried? So fried or fish is going to be that they could have eaten fish or that they picked something that was fried. So that's going to be that 65%, adding all of those. Remember, or is a bigger number than and. And has to have both, or is this or that. Okay, the last one is, what's the probability that a randomly selected person would not choose fish or fried? Well, if this is fried or fish and this is not, you already know the number out here is 35%, but you could have said, oh, the whole thing's 100. I know what this is, so it's 100% minus 65% is 35%. But in this case, we actually already knew that was 35%. For this next part, tree diagrams are my favorite, and I think they're the most helpful with probability. So I really like this part. You probably don't like the tree diagrams as much, but it says, draw sample space for tossing a coin 2 times. Draw a tree diagram and show all the possible outcomes. So again, you could flip a coin and you could get heads or tails. Then you could flip that coin again and get heads or tails. That's all you have to do. You could list it and say, oh, that's heads, 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 tails, tails, heads, and tails, tails. All right, so those are all your possible outcomes. Now it says find the probability. Well, find the probability of getting 2 tails. So your probability is going to be, for this one, how many outcomes are possible? Yeah, you only have 4 outcomes. So the probability of getting 2 tails is right here. So that's 1 out of 4. What's the probability of getting exactly 2 heads? Well, exactly 2 heads is the same thing as 2 tails. So same thing, 1 out of 4. What's the probability of getting at least 1 head? Well, at least 1 head is going to be, here you got 2, here you got 1, here you got 1. So it's going to be 3 out of the 4. All right, the next one. Draw a sample space for tossing a coin 3 times. Same idea. You're just going to draw it for 1 more coin cost. So take your time and then list them down at the end. So here I'm just listing them out. So I could get tails, heads, tails, tails, heads, heads. Now I'm here with heads, tails, tails. Okay, and you should have 8 possible outcomes. How did you know that it was going to be 8 possible outcomes? Well, you have 2 options, 2 options, and 2 options. So 2 to the third, you're going to have 8 possible outcomes. If you don't like, actually always just do the tree diagram, but this is also called like a tautology table, something like that. So you have, if you know there's 8 outcomes, 4 are true, 4 are heads, and then you split it again. So 2 tails, 2 heads, 2 tails, 2 heads, 2 tails, heads, tails, heads. You just keep splitting them. But anyways, just do the tree diagram. It's nicer. Okay, so now we're going to go to this. Listed them out. There's 8 possible outcomes. So that's our sides. Find the probability that you got 3 tails. Well, the only way to get 3 tails is if you got them all in the row. So that's going to be 1 out of 8. Probability of exactly 2 heads. And be careful with this language. Exactly 2 heads means only 2. Okay, so only 2 heads is going to be only 2. Oh, wait, we're doing heads, so not that one. Heads is going to be only 2 heads right there. Only 2 heads, only 2 heads. All right, I hope I got 3 out of 8. This one says at least 2 heads means 2 or more. So at least 2 heads, well, here you got 3 of them. Here you got okay, so in this case, your answer is going to be 4 out of the 8. So always just kind of make sure with the word exactly or at least. So this next problem is kind of nice. It says, what's the probability of rolling 2 dice? Now, I could do a tree diagram because I like tree diagrams. Now, if I would roll it once, my options would be a 1, 2, 3, 4, 5, 6. Roll the second die, I would get a 1, 2, 3, 4, 5, 6. Now, I would have to do that for each one of these. And my diagram is already messy. Okay, so I'm not going to go with that. So I'm going to do a table. It says, okay, I could get a dice of 1, 1, 2, 2, or, this is going to show you like a 1 and a 3, a 1 and a 4, 1 and a 5, 1 and a 6. It's going to show you all the combinations. Now, what they also want you to do is they want you to find out the sum of them, okay? So if you roll a 1 and a 1, the sum is 2. 1 and 2, and you're just going to complete that. So go ahead and take a minute and fill that out. Okay, and you can see it's also completed here. So it's the sum of them. You got a 1 and a 1, you get 2. If you were to get a 3 and a 5, you would get 8. Okay, so that's what it says. And again, what's our sample size? Our size is 36. So what's the probability that you would roll a two-sided die, or two-sided dice are rolled? Got it? What's the probability that the sum of the 2 dice is 7? Well, the sum is only going to be 7 right here, and it gives you all your combinations. So there is 6 out of 36, and reduce. The next one says, same thing, 2 6-sided dice are rolled. What's the probability that the sum of the 2 dice is 3? Well, the sum of the 2 dice is 3 is only going to be here and here, so that is 2 out of the 36. So 1 out of 18. The next one, 2 6-sided dice are rolled. What's the probability that the numbers on the dice are different? Okay, so in this case, I'm actually going to do the complement. I know that these are the same. And there's 6 numbers or 6 ways that the numbers would come out the same. So how many ways could I roll it that the 2 dice would be different? Is going to be the 36 minus the 6, so 30 out of the 36. Okay, and then always make sure to reduce your fraction. Oh. So again, these ones are the same. So there were 6 numbers that were the same. 1, 2, 3, 4, 5, 6. So I'm going to do the complement, 36 total. So 36 minus 6 is 30. So 30 out of 36. And reduce your fraction. Both of them divisible by 6. So 6 goes into 35 times. And 6 goes into 36 6 times. Okay, take a minute, go ahead and do this one. I'm going to read it to myself and you guys solve it. Okay, the answer is not 5 out of 36. That the sum of the dice is at least 8, so it could be at least 8, but it could also be 9, it could be 10, it could be 11, and it could be 12. So that's actually, I believe that's 15. Count that again. So 15 out of 36. Okay. And let's see, divided by 3. So 5/12. And get in the habit of reducing. Okay, what's the probability that the sum is more than 8? Okay, if it's more than 8, would it include the 8? No, it doesn't. It actually only includes, more than 8 is 9 or more. So then that would be 1, 2, 3, 4, 5, 6, 7, 10. So 10 out of the 36 numbers, so more than 8, so be careful with that. And then go ahead and reduce, so that's going to be 5 and 18 divided by 2. Okay, all right, keep going. Okay, so this next problem is actually pretty neat, and you'll have a big portion of your test will be on this page right here. It says draw a tree diagram, so we're back to tree diagrams, that shows an outcome of 2 free throws in a row. Label it accordingly. If you have an 80% free throw average, what's the probability of making both free throws? So in this case, you can have something go in and you're at 80%. We'll say that's 0.8. Well, it can either go in, or do you want to call it out or a miss? Let's see. Let's call it a miss. Okay. So if it goes in 80% of the time, then you're going to miss 20% of the time. One thing I forgot to tell you about tree diagrams is that these always, every tree branch has to add up to 100. So it's either 20, 80%, 20% has to add up to 100. So that's on their first shot. Then again, a free throw, you get 2 shots. So the same thing. It can go in 80%. You can miss 20%. And then the same thing. You can make it in 80% and you can miss 20% of the time. Now, you don't have to do this, but I'm going to go ahead and just do this, and you should do this on your notes as well. I'm going to take all of these and just multiply them. So 0.8 times 0.8, 0.64, 0.8 times 0.2, 0.2 times 0.8, you already know this, you don't need a calculator, and 0.2 times 0.2. Okay, so 0.8 times 0.8, 64%. And you can write this as a percentage or as a decimal. It's fine, either way. Now, every tree branch adds up to 100%, 100%, 100%. If I were to add up all of these probabilities, what do you think that would add up to? Yeah, it has to add up to 100%. Why? Because those are all the possible outcomes. So these, if you were to multiply these out, they have to add up to 100% because those are your outcomes. So now we have our tree diagram nicely. It shows us our options. You could go in, you can make it and then miss or miss both times and so forth. Now we're just going to answer the questions. Find the probability that you make both baskets. Well, if you make both baskets, goes in and it goes in, you have a 64% chance. All right. That doesn't sound good, but that's actually good. Okay. Probability that you miss both baskets, that's a 4% chance. Okay. So you're probably likely to make at least one. Probability that he makes at least one basket. So at least one basket means that he makes one of these, makes one of these, and makes one of these. Or in other words, it's everything except that 4%, or you could add those up, and that has to equal 96%. Okay, so you could have just done 64 plus 16 plus 16, or you could have said, oh, it's 100 minus the fact that they would miss both of them, 4%. And that's why doing these totals is nice. Okay. Same idea, another tree diagram. The accuracy of testing for allergies. Explain each of these results. Now, this one has so much more significance now, and I wish I could ask you guys if anyone has been allergy tested or things like that, but many of us have allergies, and they've done like different tests that they do. So let's just answer the problem, and then we'll talk about some of the questions. But this one's a neat one. Okay, so now, if you take a test, they're saying 99% of the people don't have allergies. 1% of the population does. And again, these are made up. But what does this tree branch have to add up? 100%. Got it. Now, the accuracy of the test. The accuracy of the test, if you have an allergy, is 80%. So the inaccuracy of the test is going to be 20%. The accuracy of the test, if you don't have allergies, is 10%. And the accuracy of the test, if you don't have allergies, or the inaccuracy is 90%. Okay, so let's go through that one more time. So has allergies, doesn't have allergies, gives an accurate reading, doesn't give an accurate reading for the people that have allergies. People that don't have allergies, it gives an accurate reading, it gives an inaccurate reading. Okay, what is a false negative? A false negative would be that it gives a negative reading, but it's wrong. You actually should be positive. What's a false positive? False positive, and you would write this down. False positive, or explain it in your own words better. False positive is that it gives you a positive test, but the result is positive, but it should really be negative. Okay? All right. Now, the question says, which is worse? You can't see this bottom part. Which is worse? A false negative or a false positive? Now think about that for a minute. Take a minute, write your answer, what a false negative is, what's a false positive. Okay, so I went back and added my definition. And again, you can write your own words. So a false negative, both of these are wrong test results, okay? But a false negative tells you that you don't have the condition, but you really are sick. You just don't know it. A false positive says that you are sick, but you don't, but you actually in reality don't have that. Okay, so let's take, for example, a instead of allergy, let's just do a pregnancy test. Okay, so in a pregnancy test, a false negative would tell you that you're not pregnant, but you really are. Okay, and then a false positive would tell you that you are pregnant, but you're really not. Well, this might be bad if you got your hopes up and were happy to start your family and all of a sudden you actually were not really pregnant. Okay, so think of different scenarios. Which is worse, a false negative or a false positive? So this sounds bad, like the example of the pregnancy because they got their hopes up, but and again, this is your whatever you think. For me, if there was a condition or a sickness that you know either maybe you're diabetic, had high blood pressure, or you were sick, this one to me would be a little bit more dangerous. If you had a false positive and you weren't really sick, you would probably, your doctor would send you to go get more tests done. And eventually they would figure out, oh, actually you either got better or you weren't really sick in the first place. But a false negative, if you were really sick and you tested that you didn't have it, well, then you would think that you were fine and you would not be taking any medication or not changing anything, and it could be getting worse when you could have prevented whatever it is, but you didn't know that because you said, oh, you're clear, so you kind of just go about your daily activities not knowing that you really should be getting some treatment. And so for me, this one, that false negative, is a little bit scary. Okay, all right. And I'm sure if you watch the news, you're hearing about all kinds of testing and all those implications. And again, how accurate are those things? Okay. Let's go to the very last problem. Okay, take a minute, read it to yourself. Try to draw a tree diagram. I'm gonna pause it and draw this. So read it to yourself, draw the tree diagram, and when you come back, it'll be up here. Okay, try to answer as much as you can. Read to yourself and solve. Well, I thought I would have my diagram complete, but there's a lot of missing information. So it says the focus group is 47% male, and of the males in the group, 40% said they would buy the fruit drink. And of the females, 54% said they would buy the fruit drink. Make a tree diagram and then find that a randomly selected person would buy the fruit drink. Okay, so this question is really important, but first I have to complete my table. So I have male or female. Well, if there's 47% male, then how many percent have to be female? Remember that they always have to add up to 100%. So 40% male buy, then how many won't buy? Okay, 60%. Of the females, 54% will buy, so then that means that 46% don't buy. Then I'm going to do the same thing and complete my diagram and multiply these across. So 0.47 times 0.4, 0.47 times 0.6, 0.53 times 0.54, 0.53 times 0.46. Multiply that out and I'm going to write those numbers. Now I can keep it as 18.8% In this case, I'm just going to go ahead and round. Now this looks good, but you have to be really careful because sometimes if you don't round the right way, remember that not only does every tree branch have to add up to 100%, this also has to add up to 100%. So if I didn't round correctly, or maybe even if I had left this as like 24.3 or 28.6, maybe this should have been a 24.4 if I had used decimals, just to make sure that they do add up correctly. So I went ahead and added 19 plus 28 plus 29 plus 24, and you guys can see that I got 100. Now, if I had kept it and left it as maybe 18.8%, 28.2%, I still would have had to add all of these to make sure that those also added to 100. So it doesn't really matter if I had used rounded early or kept it to one decimal place. Either way, always go back and just make sure that those add up to 100. Okay? All right. And then for our purposes, I'll just use this column right here. Now, this is a really common question that's easy to get wrong. It says, find the probability that a randomly selected person would buy a fruit drink. Okay, well, you could be male and buy a fruit drink. %, or you could be female and buy a fruit drink. 29%. So the probability that you would buy a fruit drink is going to be randomly selected person would buy a drink. Is actually going to be 19 plus 29. So about half of the people. Why is this confusing, or why do students miss this? Most of the time when you're doing probability, you're always multiplying. So probability that you're male and that you buy this is going to be 0.47 times 0.4. But you could have also been female and that you bought this. So that's 0.53 times 0.54. Whatever that is, and then add those two. Now, do you need a tree diagram to answer this problem? You do not. However, I think that it makes the most sense to draw the tree diagram, and it's easier that way. Again, that's easier for me, but it's kind of up to you. Okay, and that is it.